In this video we will see how we build a seismic investigation using the spatial selection. The same approach can be used for very large 3D models with millions of cells. Okay, so when building a seismic investigation, we're using a little bit of the same approach as we used when we used the ribbons buttons. We're going to display the data that we want to do analysis on. So in this case, it's going to be analysis of a near, mid, and far angle stack seismic cube. So I'm going to insert an inline from the near stack, a cross line from the mid stack, and a slice from the far angle stack. But instead of using the actual ribbons buttons that would include all the data points in this investigation, we're going to use a spatial selection probe to build this investigation. So to insert a spatial selector, we can right click on one of the seismic cubes and insert a Blueback spatial selector. So you see that we have two types of spatial selector. One is a seismic specific spatial selector that is locked to the inline and crossline direction of the seismic, and the other one is a generic spatial selector that works on all the data sets. It also works on seismic, by the way. So I'll insert a new seismic spatial selector. You see it shows up here in the display window. The object also shows up here in the input window in a designated spatial selector folder. I can now go into pointer mode, and we will now crop this spatial selector down into a relatively small area in order for us to set up the investigation and build it without it taking a long time due to all of the points we would have when we use the 3D cube. So if we went ahead and, for example, used the ribbons approach and built the investigation using all the points in the 3D cube, the processing of the investigation would take extremely long time, or in worst case it would actually crash Petrel. So that's why we start to build the investigation using data only from a very small area. So what we can do now is right click on the spatial selector and say create Blueback investigation, and that will take the data that we're displaying in the 3D window inside of the spatial selector and build the investigation from that. So here you see we have the near, mid, and far angle stacks. We are applying the spatial selector, and by default when building seismic investigations it applies a very heavy decimation. We can go down on the decimation a little bit to every fourth inline and cross line. We can always reduce this decimation later. So I will hit OK, and you see we've got the seismic spatial selector, and you see we've got the seismic investigation in the investigations folder. So let's display that in a cross plot. It needs to process the points inside of the spatial selector. So here you see we've got the near versus the mid. We can color the plot, and then you can see that we can start to manipulate. We can either move the probe around, and you see that the object, the investigation object, gets this little icon here. It means that it needs to be updated. So every time we manipulate the probe, of course the investigation needs to be updated. We can do that manually, or we can set it to refresh automatically every time we manipulate the probe. Sometimes you want to manipulate the probe and you don't want to spend the time for the automatic refresh. That's why we have the manual refresh. So now I hit the manual refresh, so we can try and toggle on the automated refresh. So when I move the probe around, you will see the plot updating automatically. So now we can try to start and expand and include more and more seismic data. And also we can go ahead and reduce the decimation, ideally down to 1 by 1. We'll just do 2 by 2 in this case. So now you see the processing already takes a little longer than it did in the initial setup. So this is how to build a seismic investigation. Thank you very much for watching.